I've built this Yagi antenna for radio amateur satellite communication. It's a 6-element, 2 meters long cross Yagi with circular polarization, right-hand circular polarization on VHF band. The antenna gain is 9 decibel. Here are basically two identical antennas at an angle of 90 degrees. This is the design I used. Links and more details about Yagis in the description. The materials. Everything is aluminum tube. The center rod is 20 mm in diameter. The radiator is 10 mm and the parasitics are 8 mm. This offers good rigidity and lightweight. I marked the position of each element on the boom. Ideally, the elements should cross at the center with zero offset. Practically, this is very hard to achieve, and the disadvantages would be even greater than advantages. So the elements of each antenna are offset by 11 mm, almost the width of the radiators. Now we have to drill the boom to pass the elements through. 6 holes for the vertical plane and 6 for the horizontal. In order to drill all the holes straight, for the elements to be perfectly aligned, in the first hole I put a rod and a water level taped to it. Then for each sequential drill, I made sure that the level is straight. Thus, at the end, all the elements were perfectly aligned. Start with the director at the front of the antenna and proceed towards the back. The element is secured in place by squeezing it a little, where it enters the center rod. This creates a bulge of either side, so that the element can't move anymore. I believe this is by far simpler, easier, good looking and accurate than using bolts, clamps and whatnot. Bă, băiete, mi-e teamă că e nasoală. The radiator construction is more complicated and require a lot of attention. Obviously, the two halves of the radiator cannot touch each other, nor the center boom. So, to unite and isolate them and ensure rigidity, I made a wooden peg out of oak treated with a primer to prevent rot. The whole assembly of the two radiators at 90 degrees is housed inside a plastic electrician's connection box. Here the coaxial cables are going to be connected. Now we have two antennas that should be connected to a single cable towards the transceiver, and we have to achieve circular polarization. We are going to use a special connection for matching and phasing. This is done using coaxial cable studs of a certain length and impedance. The two quarter wave 75 ohms studs do the matching. This is for 50 ohm impedance of the feeder and the transceiver. In order to achieve circular polarization, we have to delay the horizontal antenna in regards with the vertical one. More theory about this matching phasing technique in the link in the description. The thing is that our antennas are already offset by 11 mm, so the quarter wave 50 ohms stud for phasing is shortened with this value, well, almost taking into account the cable velocity. The vertical antenna is the most backward one. This is how the connections should be done. The results: I put the antenna on top of my rotator along with bird spikes. The environment is bad, a lot of obstructions and close to the ground. Ideally would be several meters high and hundreds of meters around flat terrain and free of obstacles. Anyway, I purchased this cheap, tiny antenna analyzer. It's extraordinarily useful and I absolutely recommend having one. The antenna SWR is outstanding, as low as 1.04, the highest value is 1.26, fantastic. The impedance is close to 50 ohm in the entire band, very little reactance. The 9 dB gain is hard to measure. Now I'm working on a similar UHF antenna using the same construction technique, and when I'll have both of them up on the rotator, then the practical results will speak up. I'm sure they will be very good. Cheers and thanks for watching.
Houston, the Eagle has landed. Roger, Tranquility, we copy you on the ground.